Hello, class. So we're going to go ahead and go over a couple other examples for dividing and rationalizing with radicals. All right, so let's do it. Okay, so it would be helpful if you can have one color to identify the rationalizing and another color for just taking your notes. All right. So I'm going to do just a little bit of a recap from our notes today, which is divide. Okay. And I'm just going to jot down. So we're going to.
Mother sea turtle swims to the
Okay.
beach.
And this
then
is
she crawls
n
up on the sand.
equals nth root a over b. And so this is the divide rule. Okay. And then I'm going to go ahead and do an exponent rule here as well. Okay, a to the n divided by equals.
Are good for
okay, so we're going to look at the pieces here that are the same and that are different. Okay, here you must have the same root. Okay, and if n is even, then a and b must be greater than 0 or positive. Now, over here, okay, we've got radical form, and here we have exponent form, okay? And what we have is same base. Notice the a is the base, okay? And you subtract the exponents. All right, we're going to do some examples. Now, how we do this is first simplify. Okay, and when I say simplify, I mean combine like terms, and that could be with our exponent rules. I mean reduce if possible. And I'm saying reduce because that's how you simplify with division. Okay, so here we go. Let's see. So I'm going to go ahead and add a second step here, and that's going to be do the, well, not necessarily square root, but do the root. Okay. Let's take a peek at our first example. So I'm going to say 15 square root 60 x to the 5th over 3 root 12x. And right here, I can put my root together because I notice they're both square roots. So I'm going to leave the outside together, okay? So this is going to be 15 over 3, and then I'm going to combine the radical, 60x to the 5th, 12x. And that's where I'm going to start simplifying and combining my like terms, or reducing if possible. All right, so I'm going to look at the numbers. So I got 60 over 12. And I'm pretty sure these things both divide by 2. Oh, and that divides by 6. So we end up with 5. Okay, and then I have x to the 5th and x to the 1st. And that reduces to, there's that exponent rule, x to the 4th. Okay, so I have inside the radical reduced. Now I need to look at outside the radical. All right, let's take this back. And I am going to leave my fraction bar here. 15 over 3 simplifies to 5 over 1. Okay, root 60 x to the 5th over 12x squared simplifies to 5x to the 4th. And notice that the denominator, it's just left with 1, okay, which would be this. All right, so I did my simplifying and combining. Now I need to actually do the root. Okay, so I'm getting good at this, so I'm just going to highlight the roots that I can simplify. So I end up with 5x squared root 5 over 1, which I don't actually have to write, over 1. So this is the final answer. Okay, let's do a second example of just the division. I'm going to go ahead and flip my page. Okay, so this time we're going to do a cube root of 64 x to the 9th y cubed over cube root of 8 x cubed y to the 12th. All right, so first I am going to see if I can simplify, okay? So I notice that these are both cube roots, and so I'm going to go ahead and put them together. All right, and now I'm actually going to do that simplifying or reducing. Okay, so I have 64 over 8, and that's easy. That's just 8 over 1. Okay, x to the 9th over x cubed is x 9 minus 3, x to the 6th. All right, not too bad. Now let's look at the y. A little bit trickier here. So we have y cubed over y to the 12th. And when we simplify that, okay, notice that I moved the 12 up, and that's why I'm subtracting the 12. But in reality, if I wanted to, okay, in this particular example, I moved the y to the 12th to the numerator by subtracting that. And so we get -9. And you're like, oh, I don't like negative exponents. So I'm going to do this a slightly different way. I don't want to move y to the 12th. I actually want to move this one down. And in order to do that, notice that the one I'm circling is the one I'm moving. And so I subtract the exponent of the piece that you're trying to move, which is, okay, be careful, notice that it's a 1 in the top because it's moving, y to the 9th. So I should leave it like this. Whereas this one, because I was moving the denominator, goes up. Oh, check that out. A negative exponent is just in the denominator. Okay, so let's write down this reduced version from what we have. Okay, 8, 1, x 6, y 9. Now, do you have to show all of this reducing work? Not necessarily. You can simply reduce from here. Now, I did the reducing. Now I'm going to do the cube rooting, and I'm just going to highlight everything that's a perfect cube. Oh, fancy that. Everything's a perfect cube. So we get 2x squared over 1 y cubed. Now you don't actually have to write the 1. Voila.